Today we are talking about the unit circle. You guys are going to be able to derive and evaluate the unit circle. Maybe not evaluate, just depends on how we get through the material today, but we are definitely going to derive the unit circle, okay? Now, the unit circle is actually something that is used to help make trigonometry easier, okay? It's actually useful in that sense, okay? It was created for that purpose. All right, it was created for that purpose. And so, a couple of notes before we get started so that you kind of know a little bit about the unit circle. Okay, a few notes before. You can just write these in on your pages. Okay, the unit circle has a radius of 1. Okay, remember taking smart notes here. Shouldn't take you long to write this stuff down. The unit circle has a radius of 1. That's what makes it special. It's not any old R value. It's 1. It's always 1. Okay? Therefore, the ordered pairs of any angle that's in standard position on the unit circle is written in that format. That's not a typo. That is cosine theta, comma sine theta. Any ordered pair that's in standard position in your unit circle is written in that form, cosine theta, comma sine theta. And the last thing is that the unit circle is comprised of degrees, radians, as well as ordered pairs. What we are going to be doing today is we are going to be deriving the unit circle. You guys are going to learn about the unit circle. Some of these things are going to sound familiar, being that you've done them in some shape, way, or form with reference angles, coterminal angles, finding the cosine of a particular number, finding the sine of a particular number, etc., etc. Okay? So we are going to be doing that today. Let's create this circle. Okay? First off, I need you to get one of your triangles. And there is a specific one that you are going to need, okay? If you hold the filled-in circle, like looking at it this way, okay? You have 3 different sizes, okay? You want the one that has a longer, if you consider the circle like the theta, you want the one that has the longer adjacent side and the shorter opposite side, okay? The longer adjacent side and the shorter opposite side, okay? And you do want to take it and you do want to flip it, okay? So you're going to be writing on the white side of it. When I made these copies, I forgot to actually, flip the ones that need to be flipped. So, instead of printing more out, this is what we have. Is everybody with me? Okay? There should be a longer adjacent side from the circle and a shorter opposite. Is everyone good? Okay. Awesome. Okay. So, basically what we're going to do to create or to derive this unit circle is we're going to use what we know about special right triangles. Went over this when we were doing trig at some point in time in this unit, okay? And you remember the special relationship that it was between the side lengths and the special right triangles? There were 2 different types. There was 30, 60, 90, and then there was 45, 45, 90-degree triangles. Those are 2 special ones. Inside the unit circle, you have special right triangles. And this first one that you have, it is a 30, 60, 90-degree triangle. So, you have a 90-degree angle here, of course, all right? And this angle is indeed smaller than the angle at the top. So this one here is going to be the 30. This one here is going to be the 60, okay? Now, when we were looking at the 30, 60, 90-degree triangles, what were the relationship between the sides in a 30, 60, 90-degree triangle? The side across from the 30 was what? The side across from the 90 was what? And the side across from the 60 was square root of 3. So basically, whatever the hypotenuse was, we took half of it to get the side that's across from the 30-degree angle. And then whatever that side is, you just multiply by the square root of 3 to get the side that's across from the 60. But because this is a triangle that's inside of the unit circle, the hypotenuse, aka the radius of the circle, is going to be how long? What's the radius of the unit circle? 1. Just wrote it down. The radius of the unit circle is 1. So this here is going to be, and actually need to write inside the triangle, it's going to be 1. Because this hypotenuse represents the radius of the circle. Like once we line everything up and we put the circle in the center, it's actually going to be the radius of that ivory colored circle. Okay? Now the side across from the 30, because it's a 30, 60, 90 degree triangle, needs to be what? It's going to be 1/2. Because again, the side across from the 30 is half of the hypotenuse. Does everybody follow me? So the hypotenuse is 2, this side is 1. Since this is the unit circle, this is 1, so this has to be 1/2. And then the side across from the 60 is nothing but the side across from the 30 times the square root of 3. So what's going to be this side here in our triangle? Square root of 3 over 2. And if you're curious on where you get that, you take 1/2 and you multiply it by the square root of 3. Since this is multiplication, it's the same thing as saying 1/2 times the square root of 3 over 1, which ends up becoming the square root of 3 over 2. That's where that's created. Okay? Now, what we're going to do, did everybody write this into their triangle? I'm hoping you wrote it into your triangle. I wasn't doing this for poops and giggles. All right? What we're going to do is we're going to take our ivory colored circle that is labeled with the quadrants. Okay, this right here, this ivory circle represents our unit circle. Okay, we're going to lay this triangle such that that circle, that filled in circle that's now, on the back side, is at the origin, and the adjacent side, the side that's labeled the square root of 3 over 2, is basically our initial side. It's on the positive x-axis. And depending on how you cut the corner where the 60-degree angle should lie right at the edge of that circle. Like so. Does everybody see it? I know it's ivory and white on the same page. You guys good? Okay. So, it should look like this. And if you're like, wait, I don't have those dots. That's because you take the red page and line it up. It should match up with that first dot. Okay? And yes, let's go ahead and let's do that. Let's glue the ivory, not the white, the ivory colored paper circle with the quadrants onto our red page here. Okay? Your quadrants should line up with the dots. Gotcha. Okay? So let's glue that down. So again, it will line up. That first dot is one of the angles on your unit circle. This dot represents one of the angles on the unit circle. And because you have, once we get everything in there, you'll have 30 degrees here, 60 degrees, the 90. This is 1/2, this is 1, this is square root of 3 over 2. This is what your little triangle looks like. This dot corresponds to what angle measure? Say again? It is 30 degrees. From its initial side to its terminal side, that is 30 degrees. This here is 30 degrees. That's what that dot corresponds to, is 30 degrees. I would hold off. I said don't glue on the triangle. If you glued it down, that's fine. That means you just got to commit to gluing down everything else. I mean, we're gonna put everything together a different way. But if you're like, Ms. Anderson, I'm just gonna glue it down. That's fine. The only issue is we're gonna end up stacking the triangles on top of each other, so then you won't be able to see everything. So, yeah. Sounds like it's gonna go. All right. Take your green paper. That's hot, isn't it? Take your green paper. Center it up and glue it to your red paper. And then take your yellow and then glue it to the back of your green. So you'll have 4 concentric circles. That's a geometry term right there. Okay. So we are basically gluing our circles together. So this is one angle that's on your unit circle, guys. This is one angle that is on your unit circle, 30 degrees. Now, because pretty much what I had to do is I had to basically take a screenshot of these pages and try to put it on the Promethean. My lines and my dots really don't line up like yours should, but this side right here should line up with this dot there. And what do you think that angle measure is right there at that dot? 0 degrees. That is another angle that is on your unit circle. If you look at those dots, if you're making the correlation, you're thinking, oh my goodness, are all these dots related to degree measures? Yes. And because you learn how to convert from a degree to a radian, they also correspond to a radian value as well. They also correspond to a radian value as well. Okay? So, give me one second. I said I was going to do this. Okay. All right. Now that we have our layers stacked, okay, you have another circle here and another circle here, correct? In the green, we are going to put the corresponding radian measure that matches up to 30 degrees, okay? And we know how to convert a degree to a radian. What's the formula to convert from a degree to a radian? Pi over 180. No need for a calculator here. Remember the trick I showed you the other day. The zeros cancel out. They both end in a 0. And this reduces down to pi over 6. Pi over 6 is what 30 degrees is as a radian. Okay? So, see, look, we only made it through the first one. You already knew what was happening. There is a pattern. Once the whole unit circle is done, there is a pattern. And I mean, a lot of students, you can even ask my seniors, right? That they remember a pattern versus in which they used to create the whole unit circle. So it's not like they remembered every individual piece where it was. They just remember the pattern. So, all right. Now the last piece, the yellow, is going to correspond to the ordered pairs because there are ordered pairs on your unit circle. And like I mentioned in the very first slide, every ordered pair of an angle that is in standard position on the unit circle is in the form of cosine theta, sine theta. Using what we've already talked about in this unit, cosine is what over what? Or R. Yes, adjacent over hypotenuse, or X over R. R stands for that radius that corresponds to the unit circle. That's why it was R and not some other arbitrary number, arbitrary letter. Okay, so you need your X value, which was square root of 3 over 2, divided by your R value, which is 1. Square root of 3 over 2 divided by 1 is just square root of 3 over 2. That is the X coordinate of that angle. Or better yet, that is what the cosine of 30 degrees is. Question? No, see, the thing is that cosine of 30 degrees is equal to the square root of 3 over 2. That's how that corresponds. So remember before I had you creating a triangle, doing the reference angle, creating the 30, 60, 90 degree triangle, and then finding the cosine. Now you just know directly what is the cosine of 30 degrees. It is the square root of 3 over 2. Sine is what over what? Opposite over hypotenuse, or y over r. Y is 1/2, r is 1. So what is the cosine, or what is the sine of 30 degrees? 1/2. And that is the ordered pair. Again, the sine of 30 degrees is 1/2, and square root of 3 over 2, comma 1/2 is the ordered pair that corresponds to 30 degrees. We are going around the circle. We are going around the circle. Okay? I guess we could do 0 before we go, before we leave 30 degrees. We could do this 0 degrees as a radian is what? It's still 0, because 0 times 180 over pi is 0. Now the ordered pair, because 0 goes all the way to the edge of the circle, it would be 1, 0. Cosine of 0 degrees is x over r, and I mean, r is still 1, so 1 over 1 is 1. And then the sine of 0 is going to be 0, because you don't go up any, so then it's 0. Questions on 0 degrees or 30 degrees? Let's go 45 degrees. All right, 45 degrees is the one that has an equal opposite side and an equal adjacent side. Okay, so out of the two you have left, it's clearly going to be this one. Okay, and because they're equal, and we already know this is corresponding to my special right triangles, what is this angle here? 45. So this is a 45, 45, 90 degree triangle. Now we already know what our hypotenuse is in this right triangle. What is it going to be? It's going to be 1, because this corresponds to the radius of the circle, which is 1. Now, in general, 45, 45, 90 was 1, 1 square root of 2. The two legs of this right triangle have to be equal. How could I find out what those two legs are? Say again. I could divide 1 by the square root of 2. Can I leave it like this? What do I have to do? What's the square root of 2 times 1? What's the square root of 2 times the square root of 2? And that is what both of your legs are in this 45, 45, 90 degree triangle. This triangle is going to lay over that other circle of your 30, 60, 90 degree triangle, like so. Okay? You're going to lay it right on top of it. That's why I didn't want you to glue it down, because then you end just gluing, like, you know. Huh? We're gonna fasten it all together. I got like a little thing that goes just gonna. Yeah. Okay. So now this is what your thing should look. You know, you got this big old circle right here. We know that. Okay, I got 45, 45. That's why I had the note on the very first page to say round the inside. Otherwise, you're not gonna be able to see it. Okay. So what does this dot correspond to? What angle measure? 45 degrees. I need to convert 45 degrees into a radian. Can someone do that real quick? Pi over 4. And now I'm going to ask you for the ordered pairs. Remember, cosine is x over r. Sine is y over r. Cosine is the x coordinate. Sine is the y coordinate. What's going to be the cosine of 45 degrees? Square root of 2 over 2. What's the sine of 45 degrees? And there's your ordered pairs. We are making our way around. We have 9 pieces of the 66 piece unit circle. Going all right? Really, all this is special right triangles. Okay? We got one more in the first quadrant. Okay? So you should have one. If you cut out like a long, like the 3s together, then you have this one next. Okay? You have this one. We're going to have to flip it around again. Now the opposite side is the longer one, the adjacent side is the shorter one. And using a little bit of logic, what's going to be this angle down here? 60 degrees. And plus, we're going around the circle. We've already covered 30 degrees. We already covered 45. So the next one clearly had to be 60. This is another 30, 60, 90 degree triangle where the hypotenuse is 1. The side across from your 30 is 1/2. And the side across from your 60 is square root of 3 over 2. Like, that doesn't change. Those side links don't change. They just change location depending on where the 30, where the 60 are. Okay? So this is what it should look like when you line it up with the others. What's this angle up here at the top? 60 degrees. I have to convert this into a radian, and then I need to do my ordered pair. This one is pi over 3. Some of y'all are already on it. Pi over 3. Now the ordered pair. The x-coordinate is what? Cosine of our angle, and our y-coordinate is sine. So cosine is x over r. What's x? And we already know r is 1, so it's going to be 1/2. Then we need sine of 60, which is y over r, which is what? Square root of 3 over 2. They all the ones that are inside of the quadrants are always over 2. Oh, thank goodness. I thought I wasn't recording for a second. I was going to cry. I was going to cry real tears. Mm-hmm. Well, 0. That's not in a quadrant. That's technically called a quadrantal angle. Okay? 0 is called a quadrantal angle. Couldn't hurt. 90 will be 1, 180, 270, and 360. Those will all be quadrantal angles. Okay? Those are going to be of a variation of how 0 was. Their ordered pair is going to be how 0 was. Okay? And let's talk about this one at the top. We know this one up here is going to be 90. What is 90 as a radian? 1/2 pi, or pi over 2. And what is this ordered pair? What do you think? It is 0, 1. Think about it. I didn't go left or right any. And I'm right basically at my y-axis, so I'm at 0 on my x-axis. And since this represents the radius of the circle, the y value is 1. You successfully completed the first quadrant of the unit circle with all the angles in radian degree and the ordered pairs. Since this technically this line right here represents the y-axis in the coordinate plane, and this point down here represents 0, 0. Your x-coordinate is still 0. You didn't move left or right any, but you are along the radius, which is 1. So the y-coordinate is 1 and the x-coordinate is 0. All the quadrantal angles are going to be a variation of 1, 0, 0, 1. And depending on where you are, it might be negative. You guys okay? All right. Like I said, after a while, it starts to create a pattern, okay? You'll start to see certain things. You will start to develop the pattern yourself, okay? Let's continue and just let you know all of the triangles are going to be a variation of the 30, 60, 90 and the 45, 45, 90 with the same lengths and everything, okay? So everything that we had just covered with those respective triangles is going to be the same all the way across the board. All of this is still the same because we're inside of the unit circle with the radius of 1, okay? So what I would like you guys to do is I want you basically to complete the rest of your triangles, okay? So in that way, I don't have to continue to go through this part, all right? Say louder. If it's in quadrant 1, will it be the exact opposite in quadrant 4? What do you mean the exact opposite? What would be the exact opposite? What are those called? No, he's ordered pairs. Jonathan asked, is like, okay, well, aren't these going to be like the exact opposite in the 4th quadrant? He's talking about the ordered pairs. What do you guys think? Probably, maybe. Okay, that's good thinking. I like that thinking. You're thinking like, okay, well, if it's all the same, maybe. If you graph it, it's going to be a reflection. I like these words, Abby. For the 2nd quadrant, all the triangles are going to be pointing with the dark circle out. Okay, all the ones in the 2nd quadrant are going to be with the dark circle pointed out. Okay? I can see the wheels are turning, and some of y'all, yes, I love it. Do we have this drawn on our next set? Okay, like I said, it's just a copy of your other ones, okay? Just a copy. Literally. Okay? There's just going to have to be just a little change because we're in the 2nd quadrant. And if we know anything about quadrants, in the 2nd quadrant, a point in the 2nd quadrant, the x-coordinate is going to be what? Negative. And the y-coordinate is going to be what? Positive. Okay? So that's going to affect our ordered pairs when we do this in the 2nd quadrant. Yes? In the 3rd quadrant, yes, you are right. The x and the y coordinates are going to be negative. What about in the 4th quadrant? Positive here, negative here. Yes, in the 1st quadrant, they're both positive. Don't forget, all students take calculus. Don't forget about that little trick there. Okay? I like how you guys are thinking ahead a little bit. You're thinking ahead. What is that all students take calculus thing? You know what? I think AJ was absent the day that we went over this. It's the other way. And this one, all of your trig functions are positive. Here, sine is your only positive one. All the other ones are negative. Well, sine in its reciprocal function. What's the reciprocal function of sine? Cosecant. So sine and cosecant are positive in the second quadrant only. In the third quadrant, tangent and its reciprocal, cotangent. Cotangent and tangent go together. They're the only ones that are positive. And then the last one is cosine and its reciprocal, secant, are the only positive ones. So that was to help you guys when it came to the triangles from the other units, the other lessons, I mean. All right. So you should have your second quadrant kind of already set up, okay? Java already set up. Mine looks a little bit different because, when I drew this, of course, the things, that's what they look like, okay? Let's work with our ordered pairs to start with, since we kind of already have an idea, or do we have an idea? What do you think this dot right here, what do you think its ordered pairs are going to be? Remember, this right here is 1/2. This is the square root of 3/2. What's the cosine? It's going to be a negative 1/2 because you are in the second quadrant. What's the y coordinate? Root 3/2. This one's not negative. You're in the second quadrant. The y's are positive. What about this point? What's going to be its ordered pair? Negative root 2/2 and root 2/2. Again, you are in the second quadrant, so your x's are negative. And what about this point here? Positive 1/2. I already did this one on the other slide, but what is this angle right here? It is 180. What's going to be its ordered pair? Negative 1/0. It's literally on the other side of my 0-degree angle, which had the ordered pair of 1/0. So once you've reflected it over the y-axis, the x's become negative. Okay? And that's basically what happened to all of our ordered pairs. Now, considering that this one right here is my 30-degree angle, in this particular triangle, this is technically a reference angle. So what is this angle here? 150. Not negative, still positive. Still positive. What about the next triangle? It's 135. Since that was 45 degrees, you just pretty much just subtract and you get 135 degrees. What about the one at the top? What's that going to be? 120. Good stuff. I'm going to ask you next. The radians. Pi is 180. And now, before anybody else shouts them out, I want you guys to give me the other ones for 120, 135, and 150. I want everyone to find out what those radian measures are. Okay? Convert them. What's 120 degrees as a radian? 2 pi over 3. What is 135? And what is 150? And all you're doing is you're just converting these using the formula. Now, do I expect you guys to use the formula? No. Yes, you need to memorize. You memorize everything. Okay? And it continues. in the same fashion for the third quadrant and for the fourth quadrant. Maybe some of y'all starting to pick up a pattern, maybe of certain things. Okay? The second number's on top. I don't know what that means. Let me tell you, okay? People see different patterns, okay? They really do. Am I going to tell you a pattern? No, I'm not. That is for you to determine yourself, okay? Because I've heard a lot, okay? It's like factoring, okay? I know like 18 different ways of how people show people how to factor. I know like at least 10 patterns with the unit circle, okay? But what works for one person might not work for you. And I have a feeling that how I do it, it definitely ain't going to work for you. All right? Okay? So you think that's going to continue for the other ones? Probably not. Okay. All right. Let's see. Some people might remember 4 different tricks or patterns, whereas one person might just remember 1. It varies. Okay? So let's look at the rest of your unit circle. So basically, once you get all your pieces in, it's going to look like this. Okay? These triangles on the inside are the same 30, 60, 90-degree triangles, 45, 45-degree triangles that we've done in quadrants 1 and 2 so far. Okay? The ones in the third quadrant are going to have, it's going to be with the whites out. The one in the fourth quadrant is going to be where the gray circle is showing. Okay? And it's all of them are just laid literally on top of each other, like all those circles just lay on top of each other. Okay? So what I want you to do for the rest of the period is I want you guys to finish this unit circle. Okay? Yes, you can. Okay? Because you already know what these little triangles are on the inside. They haven't changed. Okay? And then you can use that to help you with your ordered pairs. And then you can use the reference angle that we did at the very beginning of the period to find the next set of degrees. And then if you haven't found a pattern yet for your radians, you always have the formula to convert. Okay? So what I want you guys to do for the next 15 minutes is I want you guys to complete your unit circle with the remaining degrees, the remaining radians, and the remaining ordered pairs.